So thanks, everyone, for coming back. Hopefully you enjoyed the poster session and made a lot of connections. So next we have Esperanza Stancioff, who's going to be talking about coastal infrastructure. For those of you who don't know, Esperanza wears lots of hats in our interactions with us and a lot of other places. But one of the things she's been most involved with I don't think you're going to be mentioning very much, is the Signs of the Seasons project, which is a citizen science project across New England, monitoring phenology of plants and animals and rockweed. And for those of you who don't know very much about rockweed phenology, you should find Hannah or Esperanza later. But today she's going to be talking about coastal infrastructure resilience to climate change. Thanks.
Thank you, Abe. Can you hear me? Is this working? Okay, thanks. Well, I'm really happy to have the opportunity to talk about this project, which has been going on for over a 5-year period. And it's the only slide I'm going to show about the relevance to the coast, but because I'm sure you all realize that coastal processes for climate change are pretty complex. So this just shows that for extreme storm events, that the coast this is higher amounts of rainfall, getting to the least amount of rainfall inland. So, it's a very, we're not in a very good position for extreme rainfall on the coast. And this was in August this summer in Old Orchard Beach, failing culvert with 5 to 6 inches of rain. I'm not sure exactly what they had. And this was a failed culvert in Freeport. So you could kind of guess what I'm doing here, right? So I just want to acknowledge the funding. We started with Sustainability Solutions Initiative funding from NSF at the George Mitchell Center. And we then got more funding from NOAA, the National Sea Grant Program Coastal Community Climate Adaptation Initiative, which we were really happy to get, which allowed us to work more concentratedly in one community. And our research team from Maine, Shalene Jane, who's a professor in engineering and hydroclimatologist and with the Climate Change Institute, Alex Gray, who started out as our master's student, and then I was able to hire him on the NOAA grant as a professional through the university, and he's now happily, just as this project for him ended, he got he got a position with an environmental consulting firm, so we're really happy about all that. Narajan Dakal, postdoctorate fellow with SSI, and Mike Dandy, an undergraduate student of Shalene's in engineering. City of Ellsworth, Michelle Gagnon, senior planner, Elena Paquette, assistant planner, Michelle Veal, the city manager, and Larry Wilson, the public works director, and Maine Department of Transportation, Alex Mann. Okay. So our purpose really in this project has been to look at, what can place-based research teach us about Maine's coastal infrastructure's vulnerability in a changing climate, and what climate-related information will enable these coastal communities to address their vulnerabilities in these conditions. So those are some of the questions that we started with, and certainly it's very broad questions, and every community is unique when it comes to all of these vulnerabilities and assets and governance. And so we are looking at ways of best accomplishing this, and we pretty much worked at the intersection of the social, economic, and environmental sphere, where those intersect. And this was a great article that came out after Hurricane Sandy. You can see that this is Manhattan, a garage, near a garage in Manhattan. When they were trying to figure out, okay, now what do we do to adapt to these things, and really practicing relevant adaptation science. How do we do that? I love this quote: "Sustained interactions among researchers and decision makers are needed not only to understand how climate affects assets or resources, but also to identify how climate information can be used in decision making." So that's kind of what we're about. So this, we started with pretty much the social science. This project had social science and biophysical science components. And we started with scoping in 2 communities. Of course, a low complexity community in Lincolnville, very small, rural, coastal community, and Portland, our biggest city, with a lot of complexity and also more assets to deal with that complexity. And then we took that information that we got from them, and we created a survey that we sent to coastal community officials, 255, and then at the same time we sent it to coastal community researchers. And so basically the questions that we asked them were to rate the damage from extreme storm events, storm surge, wind, and precipitation. And we asked them to rate the damage they perceive that will occur from these storms in the next, 30 to 50 years. And finally, what types of climate-related info are currently being used to make decisions in their town, season to season and long range, 30 years and out. We also had a focus group, and some of our results we looked at on the upper left hand. You can see that blue is storm surge, green is high winds, and heavy rain is in the gold. And so the high winds and heavy rainstorms emerged as the most damaging currently, and then their perceived impacts in future extreme events was mostly that they perceived that very few said that their extreme storms would produce less in future, and saying that damage from extreme windstorms would stay the same, and more said that damage from extreme storm surge and precipitation would be increasing. So their answers varied, certainly, but we did also get an understanding from them about that 1 in 5 officials use seasonal climate projections for weather and climate decisions, and then less than 1 in 5 officials use long-range climate projections. So basically, we chose to focus on extreme precipitation events based on our survey results and from the focus group discussions and the discussions with our 2 scoping communities. And we also chose to concentrate on culverts as the major concern, because everyone has them and everybody's concerned about them. And then our governance culvert functionality was also something that rose to the top of the list from all of these different interactions with communities. So this is it's very problematic to really understand where culverts are and to understand something about them. So this is in Scarborough, and it's a part of Scarborough, and you can see the intersection where the red dots are. It's the intersection of the roads and stream crossings. And so there's usually, almost always, a culvert there or 2. And so we're able to know what the number of culverts are in that situation. And if you look at that little square at the top in red, right up here, you can see it's a very small portion of this smaller area of Scarborough. And if you zoom in on that, you can see that actually where there were no culverts, there are actually 7. And those 7 culverts were not documented anywhere. But there are very few efforts going on for towns to understand what they have, what their assets are, what the conditions are, to make any kind of planning or decisions on the culvert functionality. So data used for calculating culvert sizes in New England is based on storm frequency and duration, have not been updated since the 1960s. And these frequency and intensities have increased, and however, the software used by most engineers has not yet been updated. So while Scarborough has 125 road stream crossings, they're one of the few communities that do know what they have, and their total culverts are 2,127. So there's a big discrepancy there. In the coastal zone, we know that we have roughly 6,023 road stream crossings, and so that many culverts for that, but we have no clue what the number of culverts are for the coast. So this is just showing, this is just a visual. We can use that information to look at and rate or see how many, where the standings are for mediating this, the stormwater influence on these communities. And you can see that the most road stream crossings, and thus they have more to manage in a changing climate, are York, Biddeford, Scarborough, Augusta, and Ellsworth, containing the most. And likewise, looking at extreme precipitation increase, we can also see that some of the islands and mid-coast Maine have the most increase in extreme storm events. So we included the city of Ellsworth as a partner. They attended our focus group discussion, and we met Michelle Gagnon, the senior planner there, and she was really concerned about this discrepancy of the standards that they're using based on what they had been given. And this didn't really, she had a lot of questions, and so we decided to work with Ellsworth to find out what information can enable a municipality to make these climate-related decisions about their stormwater management, both in the present and in the future. And they were great partners to work with. The left picture is showing a road washout from a failing culvert in Ellsworth a few years back. Okay, so we have an example of a tailored information getting into the biophysical research portion, and the blue is 1981 to 2010, and the red is 1950 to 1980. So we can see that on the x-axis is, on the bottom is January through January of a given year, and what they were able to see is over this period of time how the extreme storms are occurring earlier in the year than they have in the past. And this is really essential for culvert maintenance and design and budgeting for culvert functionality in a community. And so Corinna is our closest rain gauge, and so that's the closest information data we have for being close to Ellsworth. And so this can help them in understanding better the sensitivity to these extreme events and what needs to happen. This one is showing the increase of extreme rain events, and the black line is 1950 to 1980, and the 1981 to 2010 is in blue. And this is expressing basically the difference that has occurred over these periods of time, and basically it's showing that the extreme rainfall, which used to occur every 50 years, is now occurring every 12 years. So our modeling and understanding of resizing and replacement of culverts can be better tailored from this information. And the increase in storms, in the strength of storms, is another aspect that we looked at, which gives an addition of. Sorry, I'm gonna have to read this one because it's not something I'm used to talking about. Missing that one. Sorry. Okay, so if we take a recent extreme storm, such as one that statistically occurs once in 90 years, and we can compare it to a 90-year storm of the past, find out how much the past design has decreased in effectiveness. In this case, it's 47 years. So while a culvert may have been designed decades ago to accommodate a 90-year storm, it actually accommodates far less. So that's not something that has gone into the modeling in the past, is these Hurricane Sandy-like events. It has excluded those, and this is what our researchers did, was they started to include these to see what the real story is like. So culvert functionality, this is something that we looked at very closely. This is a very simple outline schematic, but it gets very complex when you start mapping out your governance structures. And the thing about culverts is that there are so many different entities involved, and the communication is not there typically. And some of the standards are different. The local level can have a different standard than the state. And then there are certainly the permitting and regulations from agencies and the federal agency. So if you can imagine that a community might have local roads that they have to deal with, and then state roads that somebody else is dealing with, Maine DOT is dealing with, and so it gets very complicated. And our work with governance was actually a part of the Northeast chapter in the new climate assessment, regional climate assessment, national climate assessment. So in developing some tools that communities can actually use, we did a lot of GIS work, Alex did, and looking at a simple method to prioritize culverts and a visual also for town councils, for budgetary decision making, and for design perspective and management perspective on determining what the priorities should be. And you can put different values. It could be transportation as a value. It could be property values in the business district, for example. It could be most anything that these communities can make their own assumptions for and create their own priorities. So we also, for communities that do not have GIS capacity, it's expensive, and you have to have somebody that knows what they're doing, and that's probably most communities in Maine that don't have that capacity. And so we developed and wrote a little simple manual on how to do this with the use of freeware out there on the web, and we have been working with Newcastle and Damerscott on this, and they think it's just the greatest thing since sliced bread. So it's been really useful tool for them, and it's just, you can look at your assets, you can prioritize your assets, color code them, you can put all this information and click on it, you can show your community. It's been a really kind of neat thing that we're now going to have online and offer to communities. So lessons learned by researchers. We learned a lot, but this continual engagement is a necessity in order to do this work with the community. Governance is certainly critical, as I said before, in identifying these key areas, and really so that climate-related information can be addressed, can be actionable. And then ongoing training opportunities, making those available to communities as well as to ourselves. And it's really difficult to challenge the conventional or current management practices. And, this was an iterative process in every step. And adaptation is slow work. People think, here's a blueprint you can use. It doesn't work that way. It's very place-based. And some people have been in their jobs for a very long time, and it may be difficult to get them to see that these changes are occurring, or that to work with others and communicate better within communities. And as we went along, we would increase our circle of influence as we built these relationships. So education outreach was a huge thing for Ellsworth. They really wanted to include their community, and we were able to do that in several ways with them. We created a stormwater management guide, if you will, a 4-part series for educational purposes. And every time they'd have extreme rainfall event during this time, they would put up another series and introducing it by what had just happened or what some of the impacts that they'd seen. And they put it on Facebook, and they put it on their website for the city. And we put information on Maine Climate News, our website that we've created years ago. So another thing that we did was MPBN, Maine Public Broadcasting Network, did a documentary on culverts and culvert operations. And then we showed part of that at a community forum. We had 25 people sign up to attend. We had standing room only. We had over 60 people show up in this small little conference room in the city offices, and it was really great. It was really great. And at that time, College of the Atlantic students came, and they ended up working with college, with the city on a complete GIS class, 20 students, and they took this on, and they gave them a lot of resources to continue this stormwater asset and analysis that they were doing. So Ellsworth has received a community grant to continue working on their culvert assets and design and so forth. They are also assessing and making changes to current stormwater ordinances and development practices as a result. I talked about the partnership, and then we are applying these tools and process in other coastal communities. So one of my favorite quotes, building on a long history of communal achievements and tapping into a yearning for community and meaning, the way we speak about climate change must become the ultimate expression of our love for land and neighbor, for life itself. Thank you. Okay. Any questions? If they're engineering questions, I can't answer them. Obviously.
It's become evident that there was a lovely presentation in here about culverts in the park. And additionally, I've had the opportunity to find out that beaver have impact and fish have impact. In what ways does the park project will be going on with culverts and changes, and how they will implement some of these ideas? So maybe Abe could address
I think
it.
that's a question for Abe. How based on some of these things that we're doing, how do the culverts in Acadia, what's the plan? Basically, what's the plan for how to deal with the beavers with these ideas?
Actually, is Bruce in the audience?
And while you're getting to Bruce, I'll just say that this process, and this just ended, and so we've just started working in other communities, and these are easily transferable types of ideas.
So that's a long story. But, the smaller the culvert you have, the more likely you're going to have beaver problems. And so the whole process that was talked about here, where you actually match the culvert to the size of the stream channel, and you look at that in comparisons to the drainage areas, the better the chance are you'll have a functioning system, and the better chance you will not have beaver problems. But if you go the other way and you ignore that, you're just begging for problems. And if you have a small, undersized set of crossings and you have landscape alterations, meaning you have lots of clearing and you have virtually impervious surface or more flashy situations, then beaver will just compound that or accelerate that problem enormously. So, and so the more you can do for the crossings, the better you'll be prepared for the climate change things you talk about. And you'll also probably have less beaver issues. So the park is definitely struggling with that now. It's definitely something. We have crossings that were really well done by the Rockefellers, or Rockefeller and his groups. But there are also some mini crossings that are less than ideal, and that are definitely causing. Some of the ones that you talked about that are usually storm event crossings, they're not stream crossings, but they contribute quickly to a stream because they take water in flashy precipitation events and put it right into the stream, which then causes problems. So,
Thank you.
Were you able to discern a commonality of the towns or the planners of the 20% that did use climate projections in their planning for the year, or long-term planning?
You mean, did Ellsworth answer?
Of all the 250 or something you looked
Yeah.
at, you said about 20% used climate projections in their
Right.
year planning or longer range. Were you able to discern something about those towns or the planner?
In some cases where they identified where they were from, yes. I mean, you know, who they were. Oh, were they making better decisions as a result of that? Oh, it was so spotty. I mean, those that were using climate projections, it was either, every other year, or, I mean, they weren't really looking at it carefully. I would say that, from the responses that we got, there's not a lot of knowledge out there about climate projections. I'd say Portland is most sophisticated, and certainly the Sandy Beach, southern Maine communities are definitely looking at climate projections very carefully and have been for some time on sea level rise. But for this, I don't think there's very much knowledge, nor were they actually implementing any of those.
Ursa Beckford from College of the Atlantic. I just wanted to come back to the slide you had with the horizontal red and blue lines of the rainfall from 1950 to 1980 and then to 2010. And I thought it was very striking, and I was just wondering if you looked at it in shorter time periods and what the trends look like maybe every year or maybe every 5 years, as opposed to just the 30-year chunks. So
that's a great question, and no, I haven't. But I don't know. That would be a question for Shalene Jane or Nirajan Dakal. But I can't answer that question, but it's a good one. I will ask them. Yeah, we're easy to find, so if you want to shoot an email, I'd be happy to connect you with the folks that did this. Yeah.
So we have time for one more question.
Hi, I was wondering, this was presented primarily from the stormwater and gray infrastructure perspective. Bruce's comment brought it back to the natural resource and the stream simulation design, and your photos of finished projects tended to emphasize sites that were designed with the stream in mind. To what extent was that part of the outreach to communities when focusing on road stream crossings, designing so that the crossing was not a barrier to aquatic organisms and the natural function of the stream was part of the process?
Right. And every single presentation we've done, we've gotten this is a good question, and it's a valid one, and I can say that they are doing everything possible to adhere to the guidelines that DEP has, and DEP has a group of people who are, that's really their focus, and for good reason. And so I'd say yes, we are really, it's really the rules and regs too that you cannot impair these streams. So I don't know how far back that goes, but I know that Ellsworth has that concern as well.
Thanks so much.
Yeah, thank you.